Over the past few years, the world has observed firsthand the destructive effects caused when oceanic forces such as hurricanes, tsunamis, and extreme waves strike the coast. More local events, such as this storm on the coast of southern Portugal, show that Europe is also vulnerable. Despite dikes, levees, and storm surge barriers being built, there is always a chance that some of those measures cannot handle extreme weather conditions. For these occasions, it's important to have proper emergency response plans available. This is Marcel Steeve, member of the Dutch Delta Committee.
Obviously, we're facing potential climate change or accelerated climate change. Potentially, we face much more intense storms. Or storms from other directions. That means that an early warning system will be very helpful there in order to save lives. If we, through early warning systems, can incorporate these more intense conditions into our warning systems, it means that we can prevent loss of life, but also we get more insight into what actual damage will happen due to these catastrophes, and that will lead to possible interventions by policymakers. So it is a good way to incorporate our everyday findings into policymaking.
The MICORE Project is a project financed by the European Union that specifically deals with the risks of exceptional coastal storms. It includes 9 different partners from across Europe, encompassing a range of different coastal environments from the Strait of Gibraltar to the Black Sea. At each of these sites, the MICORE project aims to demonstrate the use of new and sophisticated numerical models to forecast coastal risks several days in advance, providing coastal managers with a vital time to undertake necessary risk reduction measures. Meet Paolo Chiavola, project coordinator.
The main aim of the project is to develop online tools for the prediction of the impact of storms. Basically, at the moment, you can have a weather prediction to find out if tomorrow is raining. You can have a prediction if a river is flooding. You still miss a prediction if a beach is eroding. Our main aim is to be able to produce something that can be used by coastal managers to understand what is going to happen in the next 48 hours and if there is a problem to be ready for action. The approach we have decided to use, we believe is exportable because basically everything we have done is based on open source software, so it brings the cost down quite a lot. Of course, you require to have as input to our models observations, which very often are not available, but we believe that the approach we have can be exportable not only through European countries, but also to developing countries which are typically exposed to typhoons and hurricanes and often are not aware that with approaches like ours you can defend yourself.
With a vast amount of data and analysis tools being collected and developed at each site, the MICORE project has made use of a new platform that manages data in an accountable and organized manner. The so-called Open Earth platform was developed in Delft, the Netherlands, as a means of ensuring that any data and skills developed throughout a project can be accessed and applied long after that project is finished. Work package leader Mark van Koningsveld explains.
Open Earth is a system that is trying to break down the barriers that naturally exist between people that work with data, models and tools. Usually these people are in various departments or other companies, and by removing these barriers we can make progress easier.
This approach safeguards against the loss of important knowledge and skills developed throughout the project.
In previous projects also databases have been developed to store data, but after projects are finished, and you can see that the databases are no longer maintained and they cannot be found or are rendered useless gradually. And the Open Earth system is actually project transcending, so it will remain available even after the project of MICORE is ended, and other projects can add new data to it, so the database will stay alive.
To simulate extreme storm impacts on the different European coastlines, all MICORE partners have adopted an innovative beach morphology model known as X-Beach. The X-Beach model is a numerical model that calculates how waves and currents close to the coast interact with sediments both underwater and within coastal dunes. It has been specifically developed to make it flexible to a whole range of coastal environments, as work package leader Ab van Dongeren points out.
We use universal formulations, which means that we can apply this model anywhere. And we have applied it on different coasts in Europe with good results, and actually throughout the world. And we hope that more people will use this model. It's free, it's open source, which means that people can get the model for free. They can look into the code, they can judge if it's useful for them, they can make changes, and use it anywhere they like. And we have already had applications on coral reefs and on cliff coasts and on pebble coasts, so all kinds of applications that we didn't intend it for, but people saw the use and we applied it there. The importance is that there is one platform where people can develop their formulations and their applications for their particular situation. And the importance for us in Holland is that we see what people are doing and we learn from it, and everybody's learning from each other. So it's a platform for learning, I should say.
X-Beach provides the necessary link between existing wave and tidal forecast models and the coastal zone. With this link, an early warning system informing end users about the potential for imminent threats to the population, buildings, infrastructure or habitats as a result of extreme storms has been demonstrated at each of the 9 MICORE sites.
The early warning system starts with using predictions of weather forecasts, which are transformed into wave and water levels, and these two predictions are combined to produce the morphodynamic predictions of the status of the beach. The final goal of the early warning system is to inform end users and local communities about the impact from an upcoming storm. Within the MICORE project we only produced a kind of a prototype, which was based for several test cases. So for the future there is the need to upscale the basis we provided within the MICORE project.
The way we developed the project, we decided to involve some stakeholders, but at the final part of the project we had local workshops to train the stakeholders to understand what the warning system is doing. And then the system is going to be visible on the internet, so everybody can find out if they are at risk. And of course, action is up to the government level to be taken.
Meeting and discussing the knowledge obtained from MICORE with end users is critical to ensuring that the techniques developed are useful to decision makers at an operational level. This meeting in the coastal town of Riccione in northern Italy has been held to communicate the progress made. End users such as the World Meteorological Organization and the Dutch Water Board provide their input.
This project provides one of the very good examples for the early warning system in the coastal zones, and we would like to see that this kind of examples and the procedure can be applied to other parts of the world, especially in the developing countries and those regions prone to coastal disasters.
The result of this project might be a very useful simulation program that we can use in calamity situation, that we can do real-time simulations of the storm that's approaching, and therefore we can use it for when we want to advise in this situation, then there are panic with this huge storm event, and maybe you want to advise maybe the mayor where and which people you have to evacuate or where to. And this model actually can give us these tools to do that in a very good way.
In order to build confidence in the accuracy of the numerical models, it's also important to compare the predictions with observations made in the field.
A component of the MICORE project was to do field measurements. You can imagine that if you want to measure storms, you have to catch them. So we have been working on a very short notice, typically 48 hours, to be able to mobilize, go out in the field at any time with any weather. A project like MICORE has a great socio-economic implications, because if you look at the situation like this, where you have a high touristic pressure on the coastline, the fact we can predict what is going to happen if a storm arrives can actually help to save a lot of money to the local economy.
The results of the MICORE project teach us that, that we're potentially able to make early warnings. As we do now more in river flood prone areas, where we have early warning systems already being developed for probably 10 to 15 years, we should certainly implement this in coastal regions. And the experience over the last 10 years in Europe with coastal flooding make clear that there's a lot to gain.